Hello guys, in today's grade 12 physical sciences vertical projectile motion exam clinic, we are looking at a question paper from Gauteng Province. This is Gauteng Province's physical sciences paper 1 of September 2025. This question had some issues, but don't worry, we will try to do all of them. I will highlight those issues when I get there. The important thing is what I will be showing you in this video. So once again, this question is 16 marks, and that means you must spend 16 minutes. Let's see. A learner stands on a balcony 5 meters above the street and throws ball A vertically upwards at a velocity of 5 meters per second. At the same time, another learner throws ball B vertically upwards from the street at an initial velocity of 8 meters per second. Ignore all effects of air friction. 3.1, by the way, this is question 3. So 3.1, oh boy, this is question 3. So 3.1, define projectile motion. This is motion of an object under the influence of gravity only, right? Or any other definition that you like. Motion of an object, okay? Motion of an object under the influence of gravity only. Okay, that is your projectile motion. So moving on. Calculate the maximum height above the ground reached by ball A. So we know initially ball A is 5 meters above the ground, but it will be thrown upwards. So to reach maximum height, we know its final velocity will be 0. At maximum height, final velocity is 0. We have initial velocity, which is 5 meters per second. Allow me to use this arrow to indicate upwards, right? Now we are looking for delta y. So we are good to go. I will choose upwards as positive. Okay. So I'm choosing upwards as positive, and let's go. So we will use the equation that says final velocity squared equals initial velocity squared plus 2a delta y. What is the final velocity? It is 0. Remember, we square it. What is the initial velocity? It is 5 meters per second upwards. So it's going to be positive 5 square. And then what is gravitational acceleration? Our acceleration here is gravitational acceleration, which is a downward motion. So we're going to say 2 open brackets minus 9.8 close bracket. Delta y is what we are looking for. So 0 equals 5 squared is 25 minus 19.6 delta y. If you like 19.6 delta y equals 25. Right? So 25 divided by 19.6 is, let's see, delta y therefore equals 1.28 meters. So this 1.28 meters is the distance from the balcony to the maximum height. However, the question said the maximum height above the ground. So therefore, maximum height above ground, okay? Oops. So maximum height above ground will be height of the balcony, which was 5 meters, plus distance from the balcony to maximum height. Now this says our answer is 6.28 meters. Okay, it's 6.28 meters. All right. Now, calculate the time at which the two balls will move at the same speed. Now, 3.3, it has insufficient information. Okay, 3.3 has insufficient information. You cannot solve it. Okay, it has insufficient information. All right, 3.3 has insufficient information. Okay, cool. So, having said that, and by the way, please hear me out, guys. You will try and try and try. You do not know at which position the two balls will be moving at the same speed, right? You really do not know at which position, right? So hence I'm saying it has insufficient information, so do not attempt it. Okay, only when it's like this, because indeed the information given here is insufficient. There isn't much information about object B. Okay, information on object A is sufficient, but for object B, you don't have enough. Okay, cool. All right, now let's go. 3.4. Ball A reached maximum height after 0.51 seconds. Calculate the velocity at which ball B was moving when ball A reached its maximum height. Do you guys hear this? You don't have to stress with this question. You don't have to stress about ball A. You are given a ball B. The information here, the time is given as 0.5, and you know initial velocity was 8 meters per second upwards, right? And what they want you to find is the final velocity. Once again, just say upwards is positive, right? So if upwards is positive, let's go. We will say we have final velocity. No, that's what we are looking for. We have initial velocity, we have acceleration, and we have time. We said our initial velocity is 8 meters per second upwards. Gravitational acceleration is negative 9.8, and the time is 0.51. All right, let's see now. So we have 8 minus 9.8, times 0.51. 0.51. So we have 3,002, which is basically 3 meters per second, right? Did they say magnitude? No, they didn't say magnitude, but direction. So it's a positive value, so it'll be upwards, right? Perfect. 3.5, sketch the velocity time graph for the motion of the two balls until they what? Until they reach the same speed. So something that I want you to note here is that ball B was released at the same time. So once again, upwards is positive. So this means we will have a graph with a negative slope. Okay, the information we have information of ball A. It was reaching 5 meters. Initially, it was 5 meters per second, and then it reached maximum height, isn't it? It reached maximum height. So they didn't tell us, oh, when did it reach maximum height? 0.5 seconds, 0.51 seconds. Let me just add this V in meters per second, and here it is time in seconds. And then you look at ball B, let's see, initial velocities of both. The other one was 8, the time at which ball A reaches maximum height, and the time at which the balls reach the same speed. Because this information was not given, this particular point will be ignored. So we will draw our graph like this. Okay? It's not really right. Okay, let me try to move this 8 so they can be like this. Perfect. All right. So because 3.4, the information was missing. The time at which the balls reach the same speed will be ignored, and we will have a graph that looks like this. So this is it. This is how you answer these questions. Don't worry about the information here. You will see another question in future videos that ask the same thing. Okay. All right, guys. Bye bye.